Hi guys, so our next lesson is module 11.4 and we are solving quadratic equations by factoring today. And so let's look at our learning target. I can solve quadratic equations by using the square root property. I can solve quadratic equations by factoring and sketch graphs of quadratic functions by using the zeros. And I can write equations of quadratic functions given their graphs or roots. So these are the things we are going to be learning in this lesson. So let's quickly first talk about the square root property, okay? So to solve a square root equation, to solve a quadratic equation in the form of x squared is equal to n, we take the square root of each side. So I put an example over here. And if I say x squared is equal to 49, x is equal to, it can be a square root of positive 49 or it can be a square root of negative 49, right? Because positive 7 times positive 7 gives me 49. But negative 7 times negative 7 also gives me 49. So that is why we write out the square root property in this format. Okay? So now, here's the thing. In the equation, x squared is equal to n. If n is a perfect square, you will have an integer answer. Okay, if it's a perfect square, like 49, if I have 25, I have 16, these are all perfect squares, so I will get an integer answer. Like in this case, I got 7, right? But if n is not a perfect square, you will need to keep your answers in radical form or approximate the square root. And you can use a calculator or estimation to find an approximation. Okay, so we are just going to find an approximation today if we are not getting a perfect square. Okay, if we don't have a perfect square, then that means we will not get an integer. So then, of course, we'll have a decimal value, which will be an approximation of the square root. Okay, so let's go ahead and do some examples. All right, so I put up two problems on the board and we're going to start with this one first. And it is saying x plus 5 squared is equal to 21. So I'm going to use the square root property. And that means that if I have x plus 5, if I say x plus 5, this is equal to my positive or negative square root of 21. Right? So that's the square root property. And so I'm going to go ahead and solve for this. And what I'm going to do is I'm going to use a calculator to do an estimation right there to see what square root of 21 is going to be. So using a calculator, I get this number. So when I have a long number like this, I am going to go ahead and round to the 100th place value. So I can see the 1000th place is a 2. So therefore, my answer is going to be approximately 4.58. Okay. So what is the square root of 21? Is 4.58. Okay, with a calculator. So now what I'm going to do is that I know that this can be positive or it can be negative, right? So I'm going to solve two different equations. In one, I am going to do x plus 5 is equal to my positive factor, which is 4 and 5800. So the positive square root. And then on the other one, I am going to do x plus 5 is equal to the negative square root. Okay, because we can have the positive negative, and that is the square root property. And so next I'm going to go ahead and I am going to solve for x. And so in this case, I'm going to subtract 5. Okay, using the subtraction property of equality, and I get x is equal to, and I get negative 4200. Okay, and in the other one I am going to, again, I'm going to subtract, same thing, subtraction property of equality, and I end up with x is equal to negative 9 and 58/100. Okay, so therefore each of these is a solution to this quadratic equation. Okay, so once again I can see that my solutions are this and this. So that's all I'm doing with the square root property. It's going to be positive or negative, and please feel free to use a calculator to find the square root of a number. If it's not a perfect square, you're going to get a decimal like I just did. Okay, so let's go ahead and do this one now. And so in this one, we have 16, and this is going to give me a perfect integer, right? So in this, I know that square root of 16 is 4 because that is a perfect square, right? So now I'm going to do x minus 2 is equal to 4, and then I'm going to do x minus 2 is equal to negative 4. Okay, because what do I get? I get positive negative in this case, right? So if I solve this, I'm going to do plus 2 plus 2, and I get x is equal to 6. So that is one solution. Okay, and then I am going to go ahead and do the other one where this is plus 2 plus 2, and I get x is equal to negative 2. Okay, so my solutions are x is equal to negative 2 and x is equal to 6. And that is using my square root property. Okay? So here's one more problem. And I can see that 77 is not a perfect square. So I'm going to go ahead and use the calculator. And then when I find the square root of 77, I am going to round to the 100th, and so I get 8.77. Okay, so I'm going to take square root of 77 gives me 8.77 on my calculator, and then of course I'm going to have the positive and I'm going to have the negative, right? So we are going to go ahead and do x minus 18 is equal to 77, and x minus 18 is equal to negative 77, right? The square root of this. So when I'm doing this, what am I getting? Because this is my square root and my square root, right? And so I get x minus 18 is equal to 8.77, and x minus 18 is equal to negative 8.77. Okay, and then I am going to go ahead and solve. I am adding 18 to both sides of the equation using the addition property of equality. Okay, and I end up with my solution. X is equal to, and I get over here, if I am adding 18, I'm going to get 26.77. This is one solution, and the other solution is opposite sign, so I'm subtracting, and I get x is equal to 9.23, and so here is my other solution. And this is again using square roots. Okay? All right, so here's a word problem. Solve an equation by using the square root property. We're talking about egg drop. During the egg drop competition at Anika's school, students must create a container for an egg that prevents the egg from breaking when dropped from a height of 30 feet. The formula h is equal to negative 16t squared plus h sub 0 can be used to approximate the number of seconds t it takes for the container to reach height h from an initial height of h sub 0 in feet. Find the time it takes the container to reach the ground. Okay, So now let's talk about this. At ground level, okay? So when I have ground level is going to be, what is my ground level? My ground level means my H is going to be 0. H is 0. Okay? This is a 0, if you can see from there. Okay. And then initial height is 30. And my initial height, okay? My initial height is 30 because that's where it's being dropped from. Right? And so my H sub 0 is going to be 30. All right? So therefore now, let's go ahead and write out the original equation, which is this. So we'll write that here. H is equal to negative 16t plus H sub 0. Okay? And now when I have that, I am going to put in the values, and I said H is 0 is equal to, sorry, this is t squared. There you go. All right? And so then we have, this is going to give me negative 16t squared plus, what is the value of this over here? This is going to be 30. Okay, so now I'm going to subtract 30 from both sides because I'm trying to find the value of that t. Okay, so therefore minus 30 minus 30, and I get negative 16 t squared is equal to negative 30. And then I am going to divide each side by negative 16, and I get t squared is equal to 1.875. And then of course I'm going to use the square root property, and I get an approximate because I am rounding, and I get 1.37. Okay, and here is my solution. So it takes approximately 1.37 seconds for the container to reach the ground. Okay, now notice that negative 1.37 is not going to be a solution to this. Okay, in this we're just talking about how much time does it take to reach the ground, and that is 1.37 seconds. We can't say negative 1.37 seconds, right? So therefore, please notice that over here we have a positive answer only. Okay? So let's quickly talk about the zero product property. And for any real numbers a and b, if ab is equal to 0, then a is equal to 0, b is equal to 0, or both a and b equal 0. Okay, so let's see what this means. So we are going to go ahead and do factoring using a lot of properties that we have already learned in our module 10. Okay, and so we are going to be repeating those, like factor. We are going to factor using the distributive property. We are going to factor quadratic trinomials. We are going to factor differences of squares and perfect squares. Okay, so let's go ahead and solve some problems using these properties. All right, so I've put two problems up on the board, and we are going to go ahead and solve this using the distributive property. Okay, so the first thing, let's look at that one. And we have 4x squared minus 12x is equal to 0. And so we are going to factor by using the distributive property, and we have done this in the past. What is the greatest common factor? Okay, so over here, what is common to both? I can see I have 4x. I can take that out. And then what am I left with? I am left with, if 4x is gone, I only have 1x left. And then I have minus, and if I have 4x out, I only have 3 times 4 gives me 12x. So look, 4x times x gives me 4x squared, because if I'm doing distributive property. And then 4x times negative 3 gives me negative 12x. So I have just factored it using the distributive property over here. Okay, then I'm going to use the zero product property, and that's what we were just talking about. And so we are going to say this is equal to 0 and this is also equal to 0, and that was the zero product property. Okay, and then we are going to solve for x. So in this case, if I have divided by 4, okay, so what am I doing? I am doing divided by 4 and divided by 4, so therefore x is equal to 0. Okay, and in this case I'm doing plus 3, and so x is equal to 3. All right, so here are my two solutions for x. So we again use the zero property over here, and of course we started with the distributive property for factoring, and then we use the zero product property over here, and we can always substitute the value into the equation to check if it is correct. So if x is equal to 0, 4 times 0 squared is 0. Minus 12 times 0 is 0. So 0 minus 0 is equal to 0. And yeah, that is correct. I can also substitute my x in there. So if I just to check that it is correct, all I do is substitute the value. So this is what I'm saying. I'm going to take that original equation, and if I take x is 0, that means 4 times 0 squared minus 12 times 0 should equal 0. And yeah, I do get it. And let's look at the next one. If I say 4 times, here's my other solution, 3 squared minus 12 times 3 should equal 0, and 3 squared is 9, 4 times 9 is 36, minus 12 times 3 is 36, 36 minus 36 gives me 0. So to check, this is the best way, is to substitute the value back into the equation for the solutions that I have found in order to see if it is correct and it's the correct solution, all right? And that is how we solve this. So let's look at the next question that I have over here. And I have 7x squared plus 49x is equal to 0. So what is common? My greatest common factor in this case is going to be 7x. Okay, so I'm going to take 7x out. I'm left with x plus 7 inside. So I'm using my distributive property, and this is equal to 0. Okay, so once again, greatest common factor out. And then I'm using my distributive property to rewrite it like this by factor it. And now I'm going to use my zero product property, which means 7x is equal to 0 and x plus 7 is equal to 0. Okay, so I have 7x is equal to 0 and x plus 7 is equal to 0. And then I'm going to solve for both of them. Divided by 7, x is equal to 0. In this case, subtraction property of equality. So I get x is equal to negative 7. And so here are my two solutions for this quadratic equation. Okay, it's 0 and negative 7. Once again, I can plug those values into this equation to check if it is correct. Okay, so times 0 is 0 plus 0 is equal to 0. Or I plug this in and I'm going to get the same value because, this is 7 squared. Okay, negative 7 squared times 7. And then I have the plus over here because what is negative 7 squared is nothing but 49, right? And so 49 times 7, same thing. When I am going to have the opposite signs, that is going to give me 0. Okay, so to check my work, just substitute the value in. All right, so here's a problem up here, and we have a trinomial given to us, and we are going to solve this, and then we're going to check our solution, and you're going to use the roots of x squared minus 2x minus 8 is equal to 0 to sketch the graph of the related function. So first thing that I'm going to do is I am going to go ahead and factor this out. So if I look at this one, I can see what will my factors of 8 be. So remember that the coefficient is 1 over here. So when I'm factoring a trinomial, and to know what numbers to take that I'm multiplying to get this and this, all I need to do is I need to look at the last part, which is the constant. Okay, so since I have -8, first let me look at what are the factors of 8. Okay, so it can be 1 times 8. It can be 2 times 4. Now, for me to get -8, that means my signs are going to be opposite. And we've learned about this in our module 10. Okay, and then I'm going to look at, for me to get -2x, this has got to be 2 -4. Right? So now I'm going to go ahead and I am going to use, I like my area method, so I'm just going to go ahead and use that to pull out what are my values that I have over here, okay? Because I'm factoring the trinomial. So what are my factors? So I'm going to go ahead with my area method, which is once again my personal favorite. The first number goes in the first box. The last number goes in my last box. And then the two factors that I pulled out were these two. So I can do 2x and I can do -4x. Now I can put it either way. Then I take just the first part, pull out the greatest common factor, and I get x for here. And so x times x gives me x squared. X times 2 is going to give me 2x. And then I'm looking at x times -4 is going to give me -4x. And is 2 times -4 giving me -8? Yes. So what are my factors now? So I have x plus 2 and I have x minus 4 is equal to 0. Okay, because those are my factors that I have. So I factored the trinomial. Now I'm going to use my zero product property. So x plus 2 is equal to 0. So I'm going to subtract 2 on both sides, and x is equal to -2. So that's my first solution. My second solution is saying x minus 4 is equal to 0. So I'm going to add 4 to both sides, and I have x is equal to 4. So here is my second solution using my zero product property. So now I have x is -2 and x is equal to 4. So that's the first thing that I can go and plot. Okay, so here is one solution. X is -2 and x is 4. Here is my other solution. Okay, next thing I'm going to go ahead and do is find the axis of symmetry. Okay, and so we are trying to see what is x. So opposite of b over 2a. Okay, and so what is the opposite of -2 is going to give me 2, and 2 times a over here is going to be 1. So times 1, what is 2 divided by 2? My axis of symmetry is going to be 1. So I am going to go ahead and make my dotted line because I know the vertex is going to fall on this line. Okay, so this is my axis of symmetry. Next thing I'm going to go ahead and do is I am going to calculate the vertex. Okay, and to calculate the vertex, once again, I am going to take the original equation, which is x squared minus 2x minus 8, and I am going, this is equal to y, and I'm going to go ahead and substitute the value for x. This is 1 squared minus 2 times 1 minus 8, which gives me 1 minus 2 minus 8, which I end up with -9. So therefore my vertex is going to be 1, -9. Okay, 1, -9. So Then I'm going to go ahead and plot that. So this is 1 and here is -9. So this is my vertex. Okay, and I know that the graph is opening upwards. I can easily go ahead and find, and I know it's opening upwards because that is positive in the front. That's positive, that's why. Okay, so I'm going to go ahead quickly find my y-intercept. And so for y-intercept, x is 0. Okay, my x is going to be 0, so I'm taking that same thing. 0 minus 2 times 0 minus 8, and so we have -8. Okay, so -8, and that is my ordered pair for my y intercept. So 0 and -8. So here, this is 1 point. If this is one distance away, this is one distance away on this side because it's around the axis of symmetry. And so now once I have plotted this, I know the graph opens up. So I'm going to just go and connect like this. And there's my graph. So I've sketched out the graph based on my solutions, my vertex, my y-intercept, and then I just connect knowing that it's positive because of the coefficient is positive in front of x squared. So I know my graph is opening up, and so that's how I sketch out this graph. So I'm going to go ahead and factor these two now, and these are trinomials. And so let me go ahead and I am going to go ahead and I am going to see that over here I need to put it in the ax squared plus bx plus c format. So I'm going to have to move the -20 to the other side, and for me to do that I've got to add 20 to both sides of my equation. And so this is going to be 0, and then of course this is not common, it's not a like term, so I'm going to have x squared plus 9x plus 20 on this side, and then we are going to go ahead and factor it out. I can see my coefficient is 1, so all I need to see is 20. What is going to give me 20? I can have 1 and 20. I can have 2 and I can have 10, right? I can have 4 and I can have 5. So I know that since this is positive, both my signs have to be either positive or both have to be negative. But it's positive because over here also I have plus. So I can see that this is what I am going to have over here as factors. Okay, so when I go ahead and I put this into my area method, okay, remember first number goes right on the extreme left, on the top left. My last number goes to the bottom right, and then I can take these factors and I can put 4x and 5x, because is 4x plus 5x 9x? Absolutely. Okay, and then I'm going to find what is my greatest common factor here, which is x, and I get x and I get 4. And over here I do x times 5, and I know that 4 times 5 is 20. So my factors are x plus 5 and x plus 4 will equal 0. Right? And then I am going to go ahead and solve using the zero product property. And I am going to say, let me use a different color so you can see what I'm doing. I can say x plus 5 is equal to 0. So minus 5, and so x is equal to -5. So this is one solution. All right. And then my other solution, I have x plus 4 is equal to 0. So subtract 4 from both sides. And so therefore x is equal to -4. So here is my other solution. So my solutions are x is equal to -5 and x is equal to -4. Okay, so let's do one more, and then we can talk about when we have coefficient in the front also. So this is a quick review of everything we have done in the past. Okay, so let's look at 64. And we are looking at what are my factors, okay, of 64. I have 1 and 64, right? I have 2 and 32. I have 4 and I have 16. I have 8 and I have 8. These are my factors of 64. Since this is negative, I know that my signs are going to be opposite when I am multiplying. Can be the same sign because otherwise I would have got a positive product. And so then I see negative 12x. So I can do negative 16 and I can do positive 4 to get my negative 12. Okay, so therefore now I'm going to do my area method once again for factoring. And once again, my first value goes in the top left, last value goes at the bottom right, and then I take 4x and I take negative 16x. I pull out what's common, which is x, and this is x, and I have 4, and then x times negative 16. And then 4 times negative 16 gives me negative 64. So my factors are, I have x plus 4 and x minus 16 is equal to 0. And I'm going to use a zero product property to solve for x. X plus 4 is equal to 0. X minus 16 is equal to 0. And then I am just going to go ahead and subtract 4 from both sides here. So I get x is equal to negative 4. Here is one solution. And here I'm going to add 16 to both sides. So x is equal to 16. And that is my second solution. And that is my second solution. So x is equal to negative 4 and x is equal to 16. Okay, and this is how we solve by factoring. All right. So here's one trinomial once again. I've got to put it in the correct format. So I am going to subtract 2 from both sides of the equation. So I get 7x squared minus 13x minus 2 is equal to 2 minus 2 gives me 0. So now I have it in the correct format. Now, we've done trinomials when the leading coefficient is greater than 1. So when I have that, I'm going to do 7 times my 2 over here. So here, this and this have to be multiplied. So I'm doing 7 times 2 and I get 14. Okay? Then I'm looking at the factors of 14. And I'm doing 1 and 14. So I'm going to stop right there because this has to be negative and this has to be negative. So this tells me the signs are opposite, right? And so if I do negative 14 times 1, negative 14 and I do plus 1, that's how I get negative 13x, okay? So I'm going to use these values over here and I'm going to put this into the equation. So now I'm going to make my area method and my first value is going to go in here. My last value is going to go in over here. Okay? And then I've got my 1x, right? And I have negative 14x. So what is common here is x. And so when I pull out, I get 7x and I get 1. And then 7x times, what do I have to multiply? Times negative 2 is going to give me negative 14x. And then I have 1 times negative 2 gives me negative 2. So my factors are 7x plus 1 and I have x minus 2 is equal to 0. And then I'm going to use my zero product property and I'm going to say 7x plus 1 is equal to 0, x minus 2 is equal to 0. So first I subtract 1 from both sides and I get 7x is equal to negative 1. Then I divide with 7 on both sides and I get my answer as negative 1/7. So x is equal to negative 1/7. Here is one solution. The other one, it's plus 2, and so I'm left with x is equal to 2, and here is my second solution to this problem. Okay, and that's how we solve these trinomials. So now let's go ahead and we are going to solve equations by factoring a difference of squares. Alright, so now we are doing based on difference of squares, and we are going to write it in the format a squared minus b squared. Okay, a squared minus b squared, because looking at that I know that's the difference of squares. Okay, so this is basically saying 7 squared minus x squared is equal to 0, because 49 is a perfect square, and what is the square root of 49? Is 7. So 7 squared minus x squared gives me 0. So this is saying 7 plus x, 7 minus x is equal to 0. And then I'm going to use the zero product property. 7 plus x is equal to 0. 7 minus x is equal to 0. And so in the first case, I am going to subtract 7 from both sides. And so I have x is equal to negative 7. Here is one solution. And then I am going to do, over here, I'm going to say minus 7, minus 7. That gives me negative x is equal to negative 7. So obviously I'm dividing by negative 1 because that's the coefficient, and I end up with x is equal to 7. So here is my second solution after we simplify it. Okay? Let's do this one really quick. X squared minus 121. So this is like saying again, a squared minus b squared. This means x squared minus 121 is a perfect square, because 11 times 11 is going to give me 121 is equal to 0. So we will write it out as x minus 11, x plus 11 is equal to 0, and then we are going to use the zero product property. X plus 11 is equal to 0, so this is plus 11 plus 11. X is equal to 11 is one solution. Minus 11 minus 11, x is equal to negative 11 is the other solution. Okay, so this is basically solving quadratic equations by factoring a difference of squares. Okay, now let's do one where we have, we are going to factor a perfect square trinomial. Okay. All right, so here is my question, and we are now going to again move the 45 to this other side. So subtract 45 from both sides of the equation, and I end up, of course, this is 0, and that's what I want. So I have 25y squared minus 60y, and then I have 81 minus 45, which is going to give me 36. Okay, then I look at this, that okay, what is the square root of 25 y squared, and this gives me 5y, right? What is the square root of 36 is 6 minus, so 2 times, negative 2 times 5 is going to give me 10, and times 6 is going to give me negative 60. So yeah, this is definitely difference of squares over here. Okay, so I can see that this is 5, because what is this? This is my 5y squared minus, we have the perfect square trinomial, right? So minus 2 times 5y times 6, right? Plus 6 squared, plus 6 squared. So a squared minus 2ab plus b squared. That's basically what this is. And so what does this give me? This gives me 5y minus 6 the whole squared, right? Which is equal, so all of this is equal to 0, of course, is equal to 0. So now when I am doing this, I'm doing the square root of this, okay, square root of 5y minus 6, right? The whole thing squared gives me square root of 0, square root property. And so what am I left with? I'm left with y is equal to 6/5. Y is equal to 6/5. All right? And you can check this by putting it into the original equation. Okay? So, that's how we solve the perfect squares. Let's go ahead and do another one really quick. And, okay. All right, so here's another problem. And I am again now going to add 37 to both sides. Okay, so another example, and I get 0 is equal to 9x squared minus 48x plus, we have 27 plus 37, that gives me 64. Okay, so I'm looking at that and I know that this is going to be 3x, which is the square root, and the square root of this is 8. Right? So therefore, I can say 3x, right, minus 8 squared, right, and is equal to 0. So I can, what can I do for that? I can just do the square root of that is equal to 0 squared, okay, and I end up with 3x minus 8 is equal to 0. 3x minus 8 is equal to 0. And then I am going to go ahead and do the addition property of equality, and I get 3x is equal to 8. And then I'm going to do the division property of equality, and I end up with x is equal to 8/3, and that is my solution. And that is my solution. Okay? And I can also write it as a mixed number, which is 2 and 2/3. Okay? So I can also write it as a mixed number. All right? So let's do one last problem. So now we've been given a graph of a quadratic function, and we've been asked to write the quadratic function given this graph. All right, so first thing I'm going to go and look at the two zeros on the graph. You're going to find the factors of the related expression, and the zeros are here and here, right? And so the two zeros on the graph are -2 and 6. So it's going to be x plus 2, right? We have x plus 2 and we have x minus 6, okay? Remember, I've told you if it's minus, it moves to the right. If it is plus, it moves to the left, okay? And so our function is going to be f of x is equal to a times x plus 2, x minus 6. So this is representing the graph, okay? And then after that, we know that the graph is opening upwards. So it has got to be a positive a value, right? So we are going to take another point on the graph to determine the value of a. And so let's look at 2, and we can take the vertex. Here, we're going to take this. So we've got 2, -8 is on the graph, right? So my values that I'm taking are 2, -8. I'm taking the vertex in this case, and I am going to substitute those values into the equation. So what is y is -8. is equal to a. What is x? X is 2 over here plus 2, and I have 2 minus 6. So then I'm left with negative 8 is equal to a, and I have 4. Oops. I have 4 over here, and I have negative 4. Right? And so that gives me negative 8 is equal to negative 16a. And then I am just going to divide both sides by negative 16, and I get a is equal to 1/2. Okay? So I've got my value of a. So then when I write out this equation, one equation for the function is f of x is equal to 1/2, because that's what we found a as, okay? X plus 2, and x minus 6. Okay? Or I can write this out as f of x is equal to, we have 1/2 x squared, so we are just going to use our, how we multiply trinomials, okay? Or binomials to get a trinomial, so 1/2 x squared minus 2x minus 6, okay? And that's how we solve this, and this is my equation. This is one way, and this is the factored way. Okay? And that's basically what this lesson is about. So let's go ahead and do one last problem with, points given to me. So let's look at this question. We're writing a quadratic function for the graph that contains these points. Okay, so we know that the zeros of the function occur at the x-intercepts, or when y is equal to 0. Therefore, -7 and 1 are the zeros of this function. Okay, so -7 and 1 are the zeros of this function. And so let's go ahead. This is what I'm looking at, this and this. Okay, that is my x-intercept. So therefore, the zeros of this function are, we have x plus 7, and we have x minus 1, okay? And so therefore, I am going to find the value of a in the related function, which is, this is f of x. F of x is equal to this. Okay, so we are going to use the third point, which is this, in order to find this. Okay, so we are going to go ahead and we're going to do the quadratic function with zeros of -7 and 1. Okay, and so therefore the zeros of that would be obviously +7 and -1. Then we substitute the value from here, and I get f of x is -32 is equal to a, and then I have x, which is -3 plus 7 and -3 minus 1. And so I end up with -32 is equal to -16a. And so therefore, divide both sides by -16, and I get a is equal to 2. Okay, once I've found this, I am going to go ahead and write the function. My factored form, f of x is equal to, what is a, is 2, and I have my x plus 7, and I have x minus 1. Or I can write it as f of x is equal to my 2x squared plus 12x minus 14. Okay, so either this way or this way. And that's how I find out when points are provided to me. Okay, and that's basically what this entire unit is about, solving quadratic equations by factoring. We learned how to use the square root property, right? Plus minus square root, okay, and then we, of course, we learned the zero product property. We learned how to solve quadratic equations by factoring, and we sketched the graph of the quadratic function by using the zeros, which is the x-intercept. And then I also showed you how to write equations of quadratic functions given their graphs or roots. And that concludes module 11.4, which is solving quadratic equations by factoring. So have a great day, everyone.